is a great example for you. Say you have an urn with balls in it, or a bowl with balls in it. Okay, there are 9 balls total in this here urn. You got 2 red balls, 3 white balls, 4 blue balls. You're going to choose 3 balls at random, but with replacement or without replacement. You're going to choose 3 different balls from this urn, and you're interested in knowing the number of red balls and the number of white balls that you get in your sample. Okay, so let's get the joint probability mass function. Okay, the joint probability mass function. So let's see. Maybe I could write like this, right? When I write this, I mean the probability that the number of red balls in my sample of size 3 is 0, and that I get 0 white balls also. Okay, so I take 3 balls from the urn. What's the chance that I see no red and no white? Well, that means they've all got to be blue, right? First of all, how many ways can I choose 3 things from the 2 plus 3 is 5 plus 4 is 9 things. 9 total, right? 9 balls in the bowl. 9 balls in the urn total, right? So there are 9 choose 3 ways to choose the samples, right? To choose the sample. All right, so now how many ways are there to choose 3 balls such that they're all blue? Well, I've got to get them all blue. There are 4 blue balls, right? 4 blue balls. That's 4 choose 3. Okay. I think if you do that in your calculator, you should get about 0.0476. Okay. All right. So I want what I'm after here is the joint probability mass function, which means that I need to find the probabilities for that these variables R and W take on any numbers at all. Okay, so maybe I can take a look at this. This is the chance that I see no red balls and exactly 1 white ball. Okay, so again, in the denominator, there are 9 choose 3 ways to choose the 3 balls from the urn. And then how many ways are there to choose exactly 1 white ball and no red balls? Well, that means 1 ball is white and the other 2 must be blue, right? So let's see. 1 ball is white, so that's 3 choose 1. And then by the fundamental counting principle of the universe and beyond, let's see, the number of ways that the other 2 are blue, that's going to be 4 choose 2. Right? And I think this comes out to be about 0.2143. Okay? Makes sense. Now, again, I'm after the joint probability mass function. Right? So I've got to calculate these probabilities for all possible values there. What's the chance that I see no red and exactly 2 white? Well, again, I've got 9 choose 3 in the denominator. No red. 2 of them are white, so that's 3 choose 2 times, let's see, the other one has to be blue. There's 4 choose 1 ways to do that. And let's see, if I do that with my calculator, I think I get about 0.1429. Okay. And now let's see what's next. I could also get 3 white balls, right? It's possible to get all 3 white balls. What's the probability that I get no red and all 3 white? Well, again, I've got 9 choose 3 in the denominator, and let's see, there's only one way to choose 3 things from 3 things, so, okay, and that, I think, turns out to be about 0.0119. Okay, now, how many ways are there to get, let's see, no red balls and 4 white balls? Oh, there's no way to do that, right? You can't possibly do that because you're only taking a sample of size 3. So this is stupid. We'll just skip that. We'll forget about that. So where do we go from here? Let's try the probability that we get 1 red and no white. Okay? See that? So again, there are 9 choose 3 ways to choose the balls in the bottom. And then now how many ways can I get 1 red ball and no white balls? Okay, 1 red ball. There's 2 choose 1 ways to get 1 red ball because there are 2 red balls, right? And then no white, that means the remaining 2 have to be blue, right? So it's got to be that. And I think that turns out to be about 0.1429, right? What about the chance that I see 1 red and 1 white? Okay. Again, got 9 choose 3 in the denominator. Got 2 red total, so 2 choose 1 is the number of ways to get a red ball. And then I've got 3 white, so 3 choose 1. And then I've got 4 choose 1. That means, okay, so essentially if I've got 1 red and 1 white, but I'm taking a sample of size 3, it means that I've got to see 1 red, 1 white, and 1 blue. Okay. All right. So that's why we have 3 factors there in the top. And so that, I guess, turns out to be about 0.2857. Okay. And let's see, what else? What have we not done? How about the probability that you get 1 red and 2 white? The probability that you get 1 red and 2 white, that's going to be, 2 choose 1, and then 3 times 3 choose 2, times 3 choose 2, over 9 choose 3, okay? And then, so that's going to be 0.0714. And what's the probability that you get 2 red, 0 white? That's the same as getting 2 red and exactly 1 blue, right? By the way, note that if you know the number of, I guess you already figured this out, but if you know the number of red balls and the number of white balls, if you know the number of red balls and the number of white balls that you pick in a sample, then you automatically know the number of blue balls because the total has to be 3, right? And I guess this turns out to be 0.0476. And let's see, is there anything else? I guess there's one more way, I think, unless I've screwed up here. The probability that I get 2 red balls and 1 white ball is, let's see, that's 2 red balls total, choose 2. I choose 3 in the bottom, of course, and then how many ways can I get a white ball? It's going to be 3 choose 1, right? And that works out to be about 0.0357, I think. Okay? All right. Whew. Now, if you add up all of these, that second axiom there that we had on a minute ago, it basically says that all these probabilities need to sum to 1. I can eyeball this. I guess 3.5 and about 4.5 is about 8, 15, 44, 58 or 9, and then 60 something percent, 75%, and 85, 95%, and 5%. That's 100%, I think. I don't think we've messed up. I think that's right. Joint cumulative distribution function for the number of red balls and the number of white balls. Well, so this is just I could say that this is the probability that say R is less or equal to 0 and W is less or equal to 0 is well, let's see, that's actually just the chance that they're both 0, right? So this turns out to be 0.0476. What's the probability that R is less or equal to 0 and W is less or equal to 1, say? Isn't that going to be 0.0476 plus 0.2143? Right? It's the chance that you see no reds and no whites, plus the chance that you see no reds and exactly one white. Okay. What about the probability that R is less or equal to 0 and W is less or equal to 2? Okay. Well, then, that's the probability that that you get no reds and no whites, plus the probability that you get no reds and exactly one white, plus the probability that you get no reds and two whites. Okay, so you can add those three numbers up. That's like 0.0476 plus 0.2143 plus 0.1429, etc. Or, yeah, that's the end, whatever that is. Okay. And, you could write down the probability that R is less or equal to 0 and W is less or equal to 3. Right? This is going to be, it's all the same stuff. It's 0.0476 plus 0.2143 plus 0.1429 plus 0.0119. Okay? Etc., etc.